So I'm back, still in the same clothes because this is the same video that I'm basically filming this all on the same day, but they are different parts. So yeah, good luck. I hope that it didn't annoy you to be left off at a specific point, and if it did, that means that you're very enthusiastic about learning, and good on you. And we are just going to get right back into it. Now, moving on to what I was saying. Now we're going on to slide 17. So now I'm going to show you guys this little diagram, and that's just going to show you what each of these rock textures actually looks like when you're looking at them. So the first one is coarse. You can see that you can actually see the different grains kind of distinguished from each other. Then there's fine. You can't really see that many individual grains. You can't tell them apart from each other. That is zoomed in, by the way, so it would look even smoother and less distinguishable in person. This is like using a microscope. And then there's a porphyritic texture where you can see that there's a big dark mass, and then there's like visible, like bigger grains embedded within. There's vesicular, which is like, you know, the gas bubble thing that exploded out of there and leaves cool little holes. There's glassy, where no crystal formation occurred because it cooled so quickly. And then there's pyroclastic, where it's just a mess. It looks a hot mess, honestly. But if you ever pick up a rock and it looks a hot mess, it could be pyroclastic, which means that you just picked up like the leftovers of some catastrophic volcanic eruption, honestly. Moving on from that, we're now going to get into classifications to tie this all together, and that is going to be slide 18. So basically, classification and IDing of igneous rocks just combines the two different like characteristics of a rock, of an igneous rock, in order to ID it, which are texture and composition. I'm going to show you guys a few samples as well, but there should be a big nice graph of like, I have specific ones for my classes in geology, but I can't knock into contact with my professor. Honestly, the guy who made the chart that I used to use, hi Dr. Freehoff if you're watching. So the guy who made them, I could knock into contact with him to save my life, and to be fair, he's not really an email person. He's a little older in years, so yeah, if I ever do get the charts that I used to use, I will let you guys see them in a future video, but for now, I'm going to show you guys one that I found on the internet, because I stupidly threw away most of my geology things when I realized that that wasn't going anywhere. And now I kind of, yeah, don't throw things away so hastily, you never know, okay? So yeah, it's just going to show you basically the varying textures from coarse grain to pyroclastic along like the, I would call it the y-axis if this was a graph, and along the x-axis is more mineral composition, and that ranges from like felsic to ultramafic. Notable, by the way, is the fact that you will not find a lot of ultramafic rocks at the surface, because to be ultramafic, you have to be pretty deep down, and that stuff doesn't tend to get like uncovered easily by human eyes, or by a whole lot of tectonic activity. It has to be tectonic activity specifically that brings it up, not just weathering. And unless it's weathering of a rock that was already bought up prior, etc., blah blah blah. I know that there are exceptions. Don't get pedantic with me, okay? So yeah, there's a lot of different mafic rocks, from gabbro, which is more coarse grained, to like basalt, which is more fine grained, and that's all mafic, by the way. And then like there's vesicular mafic rocks, which are scoria. And then over on the felsic side, you see like granite coarse grained, rhyolite is fine grained. You know, there's obsidian. Obsidian is pretty much just kind of its own category, because I don't know if I would even consider it really like mafic, felsic, intermediate. You can't tell what's in there really, I guess, unless you do like petrographic type tests or something like that, which I do not have access to doing. So then of course there's pumice, which is like the felsic version of a vesicular rock, and you know, tuff is the felsic version of pyroclastic, and volcanic breccia is more along the category of like mafic. And then of course there's intermediate. Diorite is my favorite rock. That's all I have to say. It looks like Dalmatians or Oreos, cookies and cream. I'm not taking any questions about that. And then obviously moving on to slide 19, it shows you another igneous rock chart for like identification purposes. And this also gets into density of like the amount of silica present. There's a lot of silica present in felsic rocks, which makes sense because a lot of it is present in the crust and like more shallow layers. And there's not a whole lot of felsic material. There's not a whole lot of like silica and mafic materials. So yeah, notable. All right, and that just shows you like this time like the no, the physical stuff is still on the y-axis, and the composition is still. Oh no, the composition is y-axis. The x-axis is physical. Sorry, I got my axes all mixed up. I have not looked at graphs in a while. So yeah. That's a nice little thing. You can pause here and look at if you want. And yeah, so moving on. There are obviously more chemical-based identifications that you can do of igneous rocks with like petrology and geochemistry and all that good stuff, mineralogy, that sort of thing. That's not my specialization. I'm not that interested in the composition of rocks, honestly, to the point where I want to have percentages of like minerals that are present or percentages of elements. It's not that deep for me, but if you guys are ever interested in that, that's a topic to look into, or several subjects anyway. And now we are on to the last slide, which is slide 20. So that's pretty much all I have for you guys. That's like my Igneous Rocks 101. I hope I explained enough for you to actually understand, you know, why I identified certain rocks the way that I did when they were igneous. And I'm also going to show you guys some samples, but so yeah, I'll just show you guys them now. This is diorite, as you guys remember, intermediate rock. You can see that there's mafic and like felsic material in there. The felsic material is lighter, the mafic material is darker, and you can see all the crystal grains. They're big enough for you to see. Or some of them anyways, although it looks like, no, yeah, this is coarse grained. This is not like fine grained, because sometimes I get confused with texture and composition, alright? Anyway, so yeah, that's diorite, a phaneritic intermediate composition igneous rock. And then of course there is, I thought that this might be vesicular basalt. That's what I identified it as in one of my earlier videos. It's very dark, it's very mafic. It is basalt, but it happens to have enough holes in it to consider it vesicular. Like I said, sometimes these IDs are a little more complex than you might think. They're not as straightforward as the charts make you think. And these are both samples of scoria, which is the vesicular type rocks as well. I have a lot of those actually. Really cool stuff. You know what I mean? And then there's granite, which is phaneritic felsic rock. You can see all the lighter materials in here. Of course, there's some darker stuff in granite because there's some darker stuff in the crust, but you can see the pink, and that tends to tell you that there's a lot of potassium feldspar present in this rock, and that tells you immediately that it's felsic, because potassium, feldspars and stuff like that, anything with that pinkish color tends not to be present in mafic rocks because it's already been weathered out, melted out, etc. before the rock formed. It's a lot more fragile than like say silica or something, or like olivine, which you see a lot of. That's darker material in mafic materials. This is, speaking of, a mafic rock, a mafic igneous rock. I do believe it's considered coarse grained. I can't remember actually what it's called, so I'll look that up for you guys real fast. Or actually, I will look it up later, right, what it is, and I will just have my editor put it in here, because I know that I've talked about it with you guys before. Diabase! That's what it is. I remember, thank God. So yeah, diabase is more mafic in material. Remember, I said that this is the stuff you can find in a lot of Pennsylvania backyards and like just around if you crack some rocks open. Yeah. And that's about it. That's all the samples that I have that are actually igneous. So basically we're moving on to the very end of this video. If there's any topics that you guys are interested in that I mentioned that I could go deeper in like depth, well, that I could go in depth about, do let me know. I will do my best. If I can't go in depth about it because I don't really understand that specific topic beyond the foundations, I will let you know. I have no problem admitting I don't know something. And I'll probably refer you to some resources that might know more than I do on that topic. Also, you are always free to do research, you know? The internet is a vast thing. You don't even have to look at encyclopedias physically anymore. Have fun, you know? But videos that I'm definitely planning on making that are deep dives into specific topics are videos on volcanoes, because there are different types of volcanoes, in case you guys didn't know. I think I've mentioned that in an earlier video too. And like, there's felsic volcanoes, there's more mafic material volcanoes, there's even intermediate volcanoes, so I'll get into that in a future video. And also, it's an excuse to talk about volcanoes and show you lots of cool eruptions. I mean, who's not going to be on board for that? And aside from that, I'm also planning a video on tectonic plate boundaries and like processes. Like, you know, convergent boundaries, divergent boundaries, hotspot volcanoes, or just rather hotspots that tend to form volcanoes, you know, that sort of thing, like mid-oceanic ridges, volcanic arcs, that kind of thing. Puerto Rico, by the way, is a volcanic arc. And cool little factoid. I'll get into those two big topics more in depth in future videos. Of course, as I said before, let me know if there's something else that you want to know about. And then, of course, I'm also planning on doing Sedimentary Rocks 101, like a big old explanatory video like this one, and Metamorphic Rocks 101, which is, you know, another category of rock ID. And then, basically, the only thing I have left for you guys is some homework, so I want you to go watch some cool videos of volcanic activity on your own, and, you know, just enjoy it, just have a good time. It's fun homework. And the other homework that you can do is, if you watched all the way to the end, if you want to let me know which igneous rock you like the most, out of all the ones that you're aware of, you drop in a comment below. I will not be judging you, because I like some pretty boring rocks in the eyes of other geologists. So, I mean, one of my favorite rocks is limestone. So, you know, who am I to judge? Just let me know, obviously, what you thought of this. If you like the formatting, suggestions for how I can make this better for you. Maybe you guys want me to get a whiteboard instead of the PowerPoint stuff. I don't know what you guys want. Just let me know. Oh, and if you want longer or shorter videos when it comes to this kind of thing, also let me know. If not, I will just keep doing my thing until I get complaints. So yeah, closing off the video. Stay curious, obviously, and have a good time doing your little homework. Bye.